This video will cover the destructive test of an unrestrained light frame wood structure model. This test is the first part of a comparative study that will investigate the behavior of a light frame wood structure model with and without the roof harness retrofit system. At 10 feet by 10 feet plan by 3 feet in eave height, the structure is a 1/3 scale model of a typical 10 meter by 10 meter by 3 meter in eave height gable roof house. The model roof has been specifically designed to emulate the behavior of the corresponding full-scale structure under similar wind loading conditions. This is achieved by reducing the cross-section of the roof truss and sheathing components while selecting a smaller nail size for the toenail connections. For this test, withdrawal of the toenail roof-to-wall connections is isolated as the failure mode, as it is typically the most catastrophic and increasingly common form of wind-induced damage to light frame wood structures. This test specifically assesses the displacement behavior of the roof-to-wall connections over a range of wind velocities. The test specimen is placed such that the ridge of the roof is perpendicular to the direction of wind flow. Visible here are the 4 trusses and corresponding roof-to-wall connections along the windward face of the model. As fan speed increases and suction is induced over the roof, displacement will occur at these locations. Wind speed is measured by the upstream Cobra probe mounted at eave height. In the following video, evidence of 3 distinct stages of failure will be visible. In order, these stages are initial displacement of the roof-to-wall connections indicating net uplift, initial full withdrawal of a single roof-to-wall connection, and lastly, full withdrawal of all roof-to-wall connections. Initial displacement of the windward roof-to-wall connections can be classified as a serviceability failure, allowing for the formation of a gap along the windward eave and allowing potential wind-driven rain to penetrate the building envelope. Full withdrawal of a single roof-to-wall connection is a structural failure, affecting the load distribution between the roof-to-wall connections and accelerating the failure process by shedding load attributed to the failed roof-to-wall connections towards adjacent roof-to-wall connections. Finally, failure culminates with all roof-to-wall connections fully withdrawn from the top plate, at which the roof is overturned about the leeward wall. In this test, however, overturning is prevented with the use of internal cabling to protect the surrounding testing environment.
All right, so the fans are currently turning on. We are currently moving to 40% fan speed from 0. We are doing 1 large log without stopping. You can see the fans. Here the fans are turning on now. The tow tube there is measuring velocity. We expect this connection and this connection to fail first. Further increasing speed. To give you a sense of the wind speed, you can observe the trees in the background. We're 25% fan speed.